Good evening, Sriyuta.
Good evening, sir.
How is your preparation, ma?
It's going well, sir.
Okay. So, last class we completed 11th portions here. So today we are going to discuss about the 12th concepts, so which are interlinked to the hydrocarbons, organic chemistry. Okay. So first I'll finish the organic chemistry, then we'll go for the inorganic chemistry. Okay. Now, so today we are going to discuss about haloalkenes and haloarenes. So what we are going to discuss means we are going to discuss about here haloalkenes and haloarenes. So what is meant by the haloalkenes and haloarenes means here in this one in alkenes. So generally what is the formula we are writing for the alkenes here? CN H2N plus 2. The general formula of the alkenes is CnH2n plus 2. In alkenes, one or more number of hydrogens are replaced by halogens is called as here haloalkenes. Okay, in alkenes, one or more number of hydrogen atoms are replaced by the halogens is called as here haloalkenes. That means how we can write as a general formula of the haloalkenes means here general formula of the haloalkenes we can write CnH2n plus 1 plus X CnH2n plus 1 X is we can write as a general formula of here haloalkane. And what is meant by the haloarenes means here? What is the simplest molecule of the haloarene actually? What is the simplest molecule of the arene? Arene is nothing but aromatic compound. Arene is nothing but here aromatic compound. What is the simplest molecule of the aromatic compound? Benzene only na? Okay, in a benzene, one hydrogen or more number of hydrogen atoms are replaced by halogens is called as a haloarenes. So what is meant by the haloarenes means here? Haloarenes are nothing but here in a benzene, one or more number of hydrogen atoms are replaced by halogens are called as a haloarenes. Haloalkanes and haloarenes are they plays an important role in a daily life. So okay, they used as a certain starting material and they used as a organic solvents to prepare organic solvents at the same time. So some haloalkanes are they used as here some medicinal purpose also. What is the best example means here? So chloroform is there. So chloroform is used as the anesthetic drug. Okay, isoleucine it is there. Okay, so sorry. Okay, so chloroform it is used as here anesthetic drug. At the same time, halothane one drug it is there. So nowadays we are not using as a chloroform as anesthetic drug. In place of chloroform, we are using as a halothane as an anesthetic drug. Okay, so we can use as a to prepare the large number of organic compounds. We can use as a to used as a solvents. Okay, carbon tetrachloride is it is used as a solvent, and carbon so chloroform also it is used as a solvent. Carbon dichloride also it is used as a solvent. So like that it is used as a solvent and all, and it is used to synthesize the some medicinal product also. Okay. Now, so based on the number of halogens, again haloalkanes and haloarenes are they classified into different types based on the number of halogens in a molecule. Haloalkenes and haloarenes are they classified into different types. Okay, based on number of halogens, they classified into different types. They classified into different types. Sir, what are the different types of the compounds we're having means here? Mono-halo derivatives. Mono-halo derivatives. Sir, what is mean by the mono-halo derivatives means here? So they contains only one halogen. The compounds which contain only one halogen means that we can call as a mono-halo derivatives. The halogens which contains only one halogen is called as here mono-halo derivatives. Okay, so what is the example for this one means here? So methyl fluoride CH3F, methyl chloride CH3Cl, methyl bromide CH3Br, and methyl iodide. So all these are the example of here mono-halo derivatives. Okay, and we can take as a chlorobenzene, bromobenzene, chlorobenzene, and bromobenzene. So bromobenzene also we can take as here mono-halo derivative, and idobenzene. So all these are the examples of here mono-halo derivatives. Okay, so dihalo derivatives. What is means here? Dihalo derivatives. Dihalo derivatives. What is mean the dihalo derivatives means if the compound is containing two halogens means that we can call as a dihalo derivatives. Sir, what are the examples means here? For example, dichlorocarbon is there. Sorry, so dichloromethane CH2Cl2. Okay, or we can write as a 1,1 dichloroethane CH3 bond CH bond Cl2. So all these are the examples. Again, based on the number of halogens attached to the carbon, dihalo derivatives are classified into two types. So one is called as a geminol dihalides. One is we can call as a geminol dihalides. Another one is called as a vicinal dihalides. So what is the geminol dihalides means if two halogens are attached to the same carbon atom is called as a geminol dihalides. If two halogens are attached to the same carbon atom is called as a geminol dihalides. If two halogens are present on the neighboring carbon atom is called as a vicinal dihalides. Vicinal dihalides. So which we can call as a vicinal dihalides means, for example, CH2 bond CH2 bond Cl bond Cl. If two chlorine atoms are present on the neighboring carbon atom is called as a vicinal dihalides. So what is the vicinal dihalides means if two chlorine atoms are present on the neighboring carbon atom is called as a vicinal dihalides. Now we got the clarity. Okay, and next trihalo derivatives. Trihalo derivatives. Trihalo derivatives. So what are the examples of the trihalo derivatives under all means? So which we can call as a trihalo derivatives means if the compounds are they contain three halogens are called as a trihalo derivatives. What is the best example for that one is chloroform. What is the molecular formula of the chloroform is CHCl3. This we can call as here chloroform. Okay, bromoform CHBr3. This we can call as here bromoform. Next, iodoform. So which we can call as iodoform is CHI3 is called as a iodoform. Okay, that we can call as a iodoform. Okay, next. So tetrahalo derivatives. What is the example means here? Tetrahalo derivatives. Tetrahalo derivatives. So tetrahalo derivatives, what is the best example means here? Carbon tetrachloride. So carbon tetrachloride is one of the best example for here. Tetrahalo derivatives. Now we got the clarity. Okay. And if we take aromatic compounds also, in aromatic compounds also we can write as a monohalo derivatives and we can write as a dihalo derivatives. What is the example of the dihalo derivatives means here? Here also Cl and here also Cl is that. This we can call as a 1,2 dihalo or dichlorobenzene. Dichlorobenzene. Okay, and one more structure we can write as So Cl bond Cl. This we can call as a 1,3 dichlorobenzene. 1,3 dichlorobenzene. So here Cl, here Cl. So 1,4 dichlorobenzene. 1,4 dichlorobenzene. Based on this one, sometimes they're asking the question. So which question they're asking means here in dichloro 1,2 dichlorobenzene, 1,3 dichlorobenzene, and 1,4 dichlorobenzene. Which one is having the greater the dipole moment means here? First one is having the greater the dipole moment. After that, second one. After that, third one. Okay. So how you're telling that means bond angle is going to be increases. Dipole moment is going to be decreases. So which one here? Bond angle is going to be increases means here dipole moment is going to be decreases. So that's why first one is having the greater the bond angle, lesser the bond angle, and greater the dipole moment. Clear? Next. Here in alkenes, halogens are attached to which carbon atom? In haloalkanes, we are calling haloalkanes. Okay, in haloalkanes, all halogens are attached to the. So, which carbon atom? What is the hybridization of the carbon here? Which hybridized carbon is that? For example, you are taking as here CH3 bond, CH2 bond Cl. Okay, CH2 bond Cl. In this one, what is the hybridization of the carbon which it is attaches with the halogen?
sp3.
sp3 very good ma. It is all halogen in haloalkanes. Halogens are attached to the sp3 hybridized carbon atom. In haloarenes, halogens are attached to the sp2 hybridized carbon atom. In haloarenes, halogens are attached to the sp2 hybridized carbon atom. In haloalkanes, halogens are attached to the sp3 hybridized carbon atom. Okay, some compounds are there. For example, so CH2 double bond, CH bond Cl is there. Okay, in this one, chlorine is going to be attached to which hybridized carbon atom here? sp2 or sp3 ma?
sp2.
So this we can call as a vinyl chloride. This we can call as here vinyl chloride and benzyl chloride. In benzyl chloride, chlorine is attached to which carbon atom? What is the hybridization of the carbon attaches with the chlorine? What is the hybridization of the carbon? So which is attaches with the chlorine? That means this one.
sp2.
sp3 ma. Alkane here. CH2 group is there. Carbon is surrounded by the 4 sigma bond. If it is surrounded by the 4 sigma bonds, means it exhibit as a sp3 hybridization. And one more example. CH3, CH2 double bond, CH bond, CH2 bond Cl. So this we can call as a benzyl chloride. Benzyl chloride. So this we can call as a allyl chloride. Allyl chloride. Okay. Now in this one, what is the hybridization of the carbon means here? sp3 only. Okay. So all this one here in some compounds it is attaches with the sp2 hybridized carbon atom and it is attaches with here sp3 hybridized carbon atom. So okay. Now so directly already you know the nomenclature. Okay, and we had seen optical isomerism also now. We had seen optical isomerism or not? Anyway, while discussing the stereochemistry chemical properties that we can discuss. So first we will check it out the preparation of the haloalkanes. How we are going to prepare the haloalkanes? Preparation of haloalkanes. So how we are going to prepare the haloalkanes? What are the different methods we are using means here? First one from alkanes also we can prepare as a haloalkanes. Sir, what is the best method means a halogenation reaction? When the methane CH4 is treated with a chlorine molecule in presence of sunlight or UV light or at high temperature. They form as a different products now. In halogenation reaction, we are getting as a mixture of products. What are the mixture of products we are getting is one is methyl chloride CH3Cl, dichloromethane CH2Cl2, and CHCl3 and CCl4. Okay, so this one here. The reaction is follows the free radical reaction mechanism. Okay, so in this one, the reaction mechanism cannot be used in the industrial sector. Why it is not used in the industrial sector means because of it is not possible to separate the mixture of products into individual products. Okay, at the same time, sometimes we used to get as a doubt, sir, why it is forming as a mixture of products? Why not it forms as a only single product? Means because of in free radical mechanism, chain propagation one step it is that. In that one, it is not possible to stop the reaction at one particular step until the completion of the hydrogens present at alkane. Okay, the reaction cannot be stopped. So due to that reason only we are getting as a mixture of products. Okay, second one. So from alkenes we can prepare here. So from where we can prepare means alkene. That means CH2 double bond CH2. If it is treated with the hydrogen bromide, if it is treated with here hydrogen bromide, if it is treated with the hydrogen bromide means it forms as a methyl bromide, CH3 bond CH2 bond Br. If you take unsymmetrical alkene, two conditions are there, CH3 bond CH double bond CH2. If it is treated with the HBr, if it is treated with HBr, or if the unsymmetrical alkene is, two conditions I can write clearly, I'll write clearly here. So one is, this is the propene actually. What is the reactant we had taken means propene. If the propene is treated with the HBr, okay, and same, the propene is treated with the HBr in presence of peroxide, in presence of peroxide. In first one, what is the product it is going to be formed, Sriyuta? Hope so, Javian, he is not understanding the concepts. Javian, are you understanding or not? Because
Yes, sir. Like,
because of
kind of I'm understanding because 2 days I did not attend the class.
yeah, so you missed some classes now. Actually,
Yes, sir.
organic chemistry, whenever you attended the continuous classes, mean then only it is possible to understand. Otherwise,
Yes,
it
sir.
is not possible to understand. Okay, you
And
missed around some three
that's
to four classes.
I'm like quite sir because I'm trying to understand.
Okay, now, so what is the answer for the Sriyuta? First one,
CH3 CHBr CH3.
CH3 CHBr bond CH3. Second one, mark CH3 bond CH2 bond CH2 Br is the product. Sir, actually these two are the examples of electrophilic addition reactions. These two are the examples of here electrophilic addition reactions. Okay, but in this one, first one it follows the Markovnikov rule. First one it follows here Markovnikov rule. Okay, second one it follows here anti-Markovnikov rule. Anti-Markovnikov rule. So what is mean the Markovnikov rule means here? According to the Markovnikov rule, in unsymmetrical alkene, the negative ion is attached with the carbon which is having less number of hydrogens. Okay. Now 1, 2, 3 carbon atoms are there. Okay. So which we can call as an alkene bond means wherever the in between carbon double bond is, that means that we can call as a alkene. That means we can consider as the first carbon and second carbon is we can call as a alkene. In that one, which carbon atom is having the less number of hydrogen? Second carbon atom. So that's why bromine is going to be attached to the second carbon atom. In second condition we are telling that anti-Markovnikov rule. What is meant by the anti-Markovnikov rule means here? The negative ion is attached the carbon which is having the more number of hydrogens in an alkene. That's why in second condition, bromine is going to be attached to the first carbon atom. Now we got the clarity. So by using this method also we can prepare as here alkenes. And one more method also is there. So for this only, if you treated with, if you added Cl2, if you added chlorine or Br2, bromine, Br2 also. If you added the bromine for the propene means it forms as a 1,2 dibromopropene is going to be formed. Okay, it forms as a 1,2 dibromopropene is going to be formed. Okay, clear? Next. What are the other reactions we are having means here? From alcohols also we can prepare. From alcohols also we can prepare as a haloalkenes. Okay, now I'm going to take as here C2H5OH. That means ethanol. If the ethanol is treated with, okay, ethanol is treated with the Lucas reagent. So what is meant by the Lucas reagent? Lucas reagent is nothing but anhydrous zinc chloride and concentration HCl. Anhydrous zinc chloride and concentration HCl mixture is called as a Lucas reagent. When the alcohol is treated with the Lucas reagent, means it forms as a CH3, CH2Cl. Ethyl chloride is going to be formed. So what is the product that is going to be formed here? It forms as a ethyl chloride. Similarly, if the ethanol is treated with the PCl3, if it is treated with the PCl3, means it forms as a 3 moles of CH3 bond CH2O, CH2Cl plus H3PO3 is going to be formed. And what is another method means here? If it is treated with the PCl5, if it is treated with the PCl5 means in this one CH3 bond CH2 bond Cl plus POCl3 plus HCl is going to be formed. Okay. Now all these are the examples of nucleophilic substitution reaction. In this one, nucleophile is replaced with. What is the nucleophile in alcohol means OH group. In alcohol here, OH group is replaced by the halogens. Okay. And one more reaction it is there. So what is another reaction? It means Argent's reaction. What is another reaction we are having means here? The Argent's reaction. Dargent's reaction. So what is meant by the Dargent's reaction means? So when the alcohol is treated with SOCl2, that is only we can call as a thionyl chloride. It forms as a CH3 bond CH2 bond Cl plus SO2 plus HCl. So Dargent's reaction is one of the best method to synthesize haloalkanes from the alcohols. Okay, Dargent's reaction is one of the best method to synthesize haloalkanes from the alcohols. Okay, so why we are calling as a one of the best method means here in this one byproducts are gases are there. It forms as a sulfur dioxide and hydrogen chloride gas. Sulfur dioxide and hydrogen chloride gases are they expel into the atmospheric air. Whenever they expel into the atmospheric air, okay, you will get as a pure product. So due to that reason only, Dargent's reaction is one of the best method to synthesize haloalkanes. Okay, and one more it is that halogen exchange reaction it is that. So what is the halogen exchange reaction means? That is only we can call as a Finkelstein reaction. That is only we can call as here Finkelstein reaction. Sir, what is mean by the Finkelstein reaction and what all means here? In this, by using this method, we can prepare as iodides. So which one we are going to prepare here? By using this method, we are going to prepare as here iodide. Sir, what is mean by the Finkelstein reaction means either ethyl chloride C2H5Cl or C2H5Br is treated with sodium iodide in presence of dry acetone. In presence of dry acetone. Okay. In this one, chlorine and bromine are replaced by iodine. That means you will get as a product is C2H5. Ethyl iodide is going to be formed. Byproduct is it forms as a sodium chloride or sodium bromide. So by using this method, it is not possible to prepare as a chlorides and bromides. Why it is not possible to prepare as a chlorides and bromides means here? Because of sodium chloride with dry acetone, it forms as a solid substance. It forms as here solid substance. So due to that reason only, it is not, this method is completely used to prepare only iodides. Okay, due to that reason, this method is used to prepare only iodides. Clear? And Schwartz reaction is that. What is another method we are having means here? Schwartz reaction. Schwartz reaction. What is mean by the Schwartz reaction means Schwartz reaction can be used to prepare the fluorides. It is used to prepare only fluorides. Okay, so how you are going to prepare as a fluorides means here alkyl halides, alkyl chlorides or bromides. That means I'm taking as a C2H5 Br. It is treated with alkyl chlorides or alkyl bromides are treated with higher metal fluoride. What are the metal fluorides we can take means here? Silver fluoride, mercurous fluoride, Hg2, F2, cobalt fluoride, COF2, antimony fluoride, SbF3. So all these are the different types of the fluorides are there. When the alkyl chlorides or bromides are treated with either silver fluoride, higher metal fluorides to form as a fluorides, that means C2H5, F is going to be formed. The reaction is called as a Schwartz reaction. Okay, and one more reaction is there. Borodine-Hunsaker reaction. What is another reaction we are having means here? Borodine-Hunsaker reaction. Borodine-Hunsaker reaction. Hunsaker reaction. Sir, what is mean the Borodine-Hunsaker reaction? What we are going to be prepared means here, by using this method, we are going to prepare only bromides. What we are going to prepare, ma? We are going to prepare as here bromides. Okay, sir, how we are going to prepare means CH3 bond, CCOOAG. This we can call as a silver carboxylate. So what is the name of this one means here? This we can write as a silver ethanoate. Silver ethanoate. It is treated with the bromine in presence of carbon tetrachloride. In presence of carbon tetrachloride, bromine is treated means it forms as a methyl bromide, CH3 bond, Br plus CO2. Carbon dioxide gas is expelled into the atmospheric air, and byproduct it forms as a AgBr. Sir, what is the difference means in a reactant and product? If you see the product means we have one carbon atom is less while comparing with the reactant. In reactant total, how many carbon atoms are there? 2 are there. In product, how many carbon atoms are there? 1 atom, 1 carbon. So how many carbon atoms are decreases means here? So 1 carbon atom is less. So product is having 1 carbon atom is less while comparing with the reactant. Okay. Got the clarity?
Yes, sir.
Okay, so these are the different types of the reactions we are using the preparation of the haloalkenes. Okay, then shall we see how to prepare as a haloarenes? Okay, now we will check it out the preparation of the haloarenes. Preparation of haloarenes. Okay, haloarenes are nothing but aromatic halogen containing compounds. Okay, in this one, how we are going to prepare means first one here. Let us see. First, I am taking as a benzene. First, I am taking as a benzene. In the absence of the light R, when the benzene is treated with chlorine in presence of iron in dark condition, means it forms as a chlorobenzene. It forms as a chlorobenzene. If in presence of light means it forms as a benzene hexachloride. That means more number of chlorine atoms are replaced by the hydrogens. Okay, in presence of sunlight means here in a benzene, more number of hydrogen atoms are replaced by the chlorine. So due to that reason only the reaction is carried out in dark condition. So when the benzene is treated with the chlorine in presence of iron in dark condition means it forms as a chlorobenzene. Okay, so what are the other methods we are having in the preparation of the haloarenes means? One is we are having Sand-Meyer reaction. Sand-Meyer reaction. Sir, what is meant by the Sand-Meyer reaction means here? First, we are taking as a aniline. First, we are taking as a aniline. So when the aniline is treated with sodium nitrite, NaNO2, in presence of HCl at 0 to 5 degrees centigrade of the temperature. So when the aniline is treated with the sodium nitrite in presence of HCl at 0 to 5 degrees centigrade means it forms as a benzene diazonium salt. Okay, so what is the product it forms? Benzene diazonium salt. Benzene diazonium salt. When the benzene diazonium salt is treated with cuprous fluoride, Cu2, Cl2 in presence of HCl. Cu2Cl2 in presence of HCl means it forms as a chlorobenzene. What is the product it forms here? It forms as a chlorobenzene. If it is treated with cuprous bromide, Cu2 Br2 in presence of HBr, it forms as a bromobenzene. Sir, by using this method, that means by addition of the cuprous iodide, it is not possible to form as a iodobenzenes. So we have to take as some separate method. So what is the separate method we are using in the preparation of the ionobenzene means here? So benzene diazonium chloride is treated with potassium iodide. It is treated with here potassium iodide. It is heated with potassium iodide. If it is treated with the potassium iodide, then only it forms as a ionobenzene. Then only it forms as a ionobenzene. Sir, what are the byproducts it is forming? Means byproducts are it forms as a nitrogen gas. Nitrogen gas is expelled into the atmospheric air. Now we got the clarity. Okay. And
Yes, sir.
one more method is there. So what is another method we are using in the preparation of the haloarenes means here? Getterman reaction. Okay. Getterman reaction. Getterman reaction. So what is mean by the Getterman reaction? What is mean by Getterman reaction? So what is mean by the Getterman reaction means? In Getterman reaction also, we are taking as a reaction intermediate is benzene diazonium chloride. But reactants are going to be different. Okay. So what are the different means here? If in Getterman reaction, when the benzene diazonium chloride is treated with copper in presence of HCl, copper in presence of HBr. Okay, copper in presence of HCl means it forms as a chlorobenzene. Copper in presence of HBr means it forms as a bromobenzene. Similarly, if the benzene diazonium salt is treated with the copper cyanide, CuCN means it forms as a cyanobenzene. It forms as here cyanobenzene. Okay, but by using this method, we are going to prepare only fluorides and bromides and iodides. We didn't prepare as a fluorides. Okay, so direct fluorination does not takes place. How we are going to prepare as a fluoride means here like Blaise-Skimman reaction or Blaise-Skimman reaction also we can call. In the Blaise-Skimman reaction, we are going to prepare as a fluorobenzene. Blaise-Skimman reaction. So by using this method, we can prepare only fluorides. By using this method, we can prepare only fluoride. Okay. So first what we are taking as a benzene diazonium salt only. First what we are taking, we are taking as a benzene diazonium salt. When the benzene diazonium salt is treated with, so tetrafluoroboric acid. It is treated with here tetrafluoroboric acid. If it is treated with the tetrafluoroboric acid means it forms as a reaction intermediate. What is the reaction intermediate it forms means here? Benzene diazonium tetrafluoroborate is going to be formed. Benzene diazonium tetrafluoroborate. It is highly unstable. By heating at high temperature, again it undergoes to the decomposition reaction. Finally, it forms as a fluorobenzene and nitrogen gas is going to be released and BF3 is going to be formed. Okay, so by using this method also we can prepare as a fluorobenzene. So what is the method we are using in the preparation of the fluorobenzene Blaise-Skimman reaction. So now we understood here until here.
Yes, sir.
So all these are the different methods of preparation of the haloalkanes and haloarenes. Okay, next we are going to check it out for here. Physical properties. What are the physical properties of the haloalkenes and haloarenes? Next one, physical properties. What are the physical properties of the haloalkenes and haloarenes?
Sir, they're colorless.
Very good one. Colorless.
They also have a sweet smell.
Physical properties. Physical properties. So what are the physical properties means here? First of all, it is colorless only, ma. Okay. In that also some clarity it is there here. What is the clarity means here? Lower halo alkenes. Lower halo alkenes are colorless gases. Colorless gases. Sir, what are the examples of the colorless gases means here? Methyl fluoride, methyl chloride, methyl bromide, methyl iodide. So all those are the colorless gases only. Okay, so lower halo alkenes are they are colorless gases. Okay, and higher halo alkenes. Okay, higher halo alkenes. So they are here liquids. Some of the higher halo alkenes are here liquids, and some other here solids. Some other are here solids. Some halo alkenes are here solids. In this one, sir, chlorides and bromides. Chlorides and bromides are chlorides and bromides are colorless. Sorry, chlorides and fluorides are colorless. Chlorides and bromides are chlorides and fluorides. Chlorides and fluorides are colorless. But bromides and iodine are, they'll give as a color because of iodine is in violet color, bromine is reddish brown color, it will be there. Fluorides and chlorides are colorless. Okay, and bromides and iodides are starting, it will be colorless. Slowly they change into the color. Slowly they change into the color. Slowly they change into the color. So now you got the clarity.
Yes, sir.
Okay, now you got the clarity or not? Okay. And solubility. So once you check it out, the solubility is haloalkanes and haloarenes are there soluble in a water. Haloalkanes and haloarenes are insoluble in a water. So because of that, does not form as a hydrogen bonds with the water molecule. Okay. Now, what is the reason means here? Haloalkanes and haloarenes are insoluble in water. Okay, so because they does not form hydrogen bond, because they does not form hydrogen bond, because they does not form as a hydrogen bond. Okay, they are highly soluble in organic solvent. They are highly soluble in organic solvents. Okay, now, and what about the boiling point and melting point? Boiling points में here, boiling points of the haloalkanes. First of all, let us see the boiling point of the haloalkanes. So what is meant by the boiling points means here mass is going to be increases. That means Ri, Rbr, RCl, Rf it is there. So which one is having the high boiling point temperature? The alkyl halide which is having the high molecular mass, that it has the high boiling point temperature. So according to that one, which one is having the high boiling point temperature means here alkyl iodide is having high boiling point temperature than alkyl bromide. Alkyl bromide is having high boiling point temperature than alkyl chloride. After that, alkyl fluoride. Okay, and in this one, if the surface area, that means straight chains are there. So branched chains are increases. Branched chains are increases. The boiling point temperatures are going to be decreases. Okay, so boiling point temperatures are going to be decreases. Sir, what is the example for that one means here? In this one, so 1-chlorobutane, 1-chlorobutane, isochlorobutane, 1-chlorobutane and isochlorobutane. In 1-chlorobutane and isochlorobutane, which one is having the high boiling point temperature?
1-chlorobutane.
1-chlorobutane is having here high boiling point temperature. And one more question here. So previous year MSET level question and NEET level question also here. So here dipole moment and density also is going to be increases. Density also is going to be increases if the mass is going to be increases. Now based on the dipole moment, they're asking one question here. What is the dipole moment question? Means CH3Cl, CH2Cl2, CHCl3 and CCl4. Sir, which one is having the greater the dipole moment? Or they're asking increasing order or decreasing order of the dipole moment. Okay, so what is the decreasing order of the dipole moment, ma? Which one is having the greater the dipole moment? Means here methyl chloride is having the greater the dipole moment than dichloromethane. After that chloroform, finally carbon tetrachloride. Finally, carbon tetrachloride is having the least dipole moment. This one is here, dipole moment. Dipole moment. So this is the question also they asked. Okay, so arrangement. So which one is having the highest dipole moment? Means chloromethane. After that, dichloromethane. After that, trichloromethane. After that, carbon tetrachloride. Okay, so this is about the physical properties of the haloalkanes and haloarenes, and we'll see the chemical properties tomorrow. Okay, ma?
Okay, sir.
We'll continue tomorrow, friends. Okay, right.
Thank you, sir.
Javian, better to check it out the previous
Thank you,
class.
sir.
Okay.
Yes, sir. I will. I will.
First, you go through the previous class, then you can understand. Okay.
Yes, sir.
Right, sir.
Thank you, sir.
You're welcome.